Hello guys, welcome to Designing by SolidWorks. Today we'll learn how to create a 3D model using the Loft feature. The Loft feature is created by blending two or more similar or dissimilar sections together to get a free-form shape. You can invoke the Loft property manager by choosing the lofted boss base option in the feature command manager. It is not available right now, it is showing here. It adds material between two or more profiles to create a solid feature. So we first need to sketch two profiles to make this option available. Let's go to sketch and draw two profiles first. Select the top plane. I'll draw a rectangle here. Let's add dimension to it. 100 mm and this one's 100 mm. So now our sketch is fully defined. Let's exit the sketch. Now we have to make a reference plane to offset to the top plane to make the second profile. So let's do that. Go to features and reference geometry. Select plane. In the first reference, give top plane. And the offset distance is 150 mm. Click OK. See, now you have a second plane offset 150 mm to the top plane. Right click on that plane and select sketch. Now I will draw a circle here. Add dimension as 50 mm. Now exit the sketch. Now the lofted base or boss tool is now available. Click on it. See, now the left hand side in the property manager you can see some options like profiles, start or end constraints, guide curves, centerline parameters, sketch tools and options and the thin feature. In the profiles, the sketch 2 is already selected. Select the sketch 1 2. So now you can see the feature in the shaded graphics right here. See, it adds a solid material between the two profiles you have selected. See, the green point showing here, this is the handle of the connectors. You can select this and drag this one like this. See, your lofted is now twisted. The feature, you can drag it and make your feature as you want. See, okay. If I click OK, see the feature right now. It connected those two profiles. Now let's go back to edit the feature. In the start or end constraints, you can see two options like start constraint, end constraint. In the drop down you can see two options, direction vector and normal to profile. What direction vector does is, this option is used to define the tangency at the start and at the end of the loft feature by defining a direction vector. How that's done we'll see next. First let's select the normal to profile option. What this option does is, it is used to define the constraints at the start and the end sections of a loft feature. That means the loft is now normal to the two profiles here. See, there are two options when we select the normal to profile option. First one is the draft angle. You can select this is as normal draft outward. If you reverse the direction, it will draft inward. You can specify the angle right here. If I want to draft is 10 degree. See what happened, it drafted outward the loft. If I select the to reverse direction, see Now it is drafted inward. And the second option is start tangent length. So if I select this length, that means you can see here this loft feature is now normal to the profile right now. If I increase this value, you can see that normal length or the tangent to the profile length is now increased up to 3. So if I decrease, see, select as 1, that means up to 1 millimeter the loft is tangent to the profile. You can also reverse the tangent direction. Below that is the apply to all button. You can see here one purple or violet, I don't know what it is. Its arrow is shown here. So if I select apply to all, if I unselect apply to all, see there are other 3 arrows at the 3 handle of the connectors. You can individually apply different tangent length and different draft angles to them. You can also add connectors like this. Here add connector, show all connectors, hide connectors. Here are some options. Add connector right here. See, there is another connector added, and you can drag it to make your feature more smooth. You can also delete this connector. See, here it is the end constant option. If I select normal to profile, there are also the same options like the start constraint. The end constraint is now selected as normal to profile. That means the loft feature is now normal to the end profile. You can increase the draft angle and you can increase the tangency length. The apply to all button is defaultly selected. The next one is guide curves. What guide curves do is you can create a loft feature by specifying the guide curves between profiles to define the path of the transition of loft feature. The sketches for the guide curve need to coincide the sketches that define the loft sections. So they basically provide a particular path, they guide the loft along to the profile, next profile. So the next one is Centreline Parameter. What Centreline Parameter does is it is used to create a loft feature by bending 2 or more than 2 sections along a specified path. You add a center line between the profiles and it will guide the loft feature about that center line or about that path. How it is done, let's see. Delete the loft. Yes. Now let's add a center line. So see, this one is the top plane we selected and this one is the new plane we created, and the intersecting plane that passes through the mid plane of these two planes are the front plane and also the right plane. So let's select the front plane, select sketch. So let's now create an arc, simple arc, 3 point here, and this, set the dimension, set it as 140. Okay, now exit the sketch, go back to the lofted feature. In the profiles, select the sketch 1 and sketch 2. Okay, so now in the guide curves it is selected as sketch 5, but this is not the guide curve, this is a center line option, so delete it. Now you can see the preview right here. Go to the Centreline feature and select the curve. See, now you can see the preview in the shaded graphics right here. What you can see is our loft is guided by that center line, by that arc. Down in the Centreline feature you can see there is a number of sections option, source sections, and this one is the section number. This is used to define the number of intermediate sections, which further defines the accuracy and the smoothness of the loft curve, loft feature. So you can add more sections like in between two profiles, so that your curve will be more accurate, your loft will be more smooth. The next option is the sketch tools. What sketch tools option is, you can add 3D sketches as profiles or guides for the loft feature. What are 3D sketches? We haven't seen that yet. We'll learn about them in the upcoming videos, so for now let's just skip this part and we'll come back to this when we learn about 3D sketches. So let's go back to the starter and constraint and the direction vectors. In the direction vector you can see there is a selection where you can select the direction vector, the draft angle, and the start tangent length option and apply to all. So what direction vector option does is, this option is used to define the tangency at the start and at the end of the loft feature by defining another direction vector. So we need to select a direction vector to specify the tangent at the start and the end of the feature. So we first need to sketch a profile for the direction vector right here. So let's do that. So now let's sketch a profile. Create a new document. Sketch. Okay. Now set relation between these three lines as symmetric. Okay, now our sketch is fully defined. Now let's exit the sketch. See, these two sketches are on the top plane. So now let's select the front plane to sketch the profile for the direction vector. Let's create another rectangle. $20 set the distance 50. Sorry, this one is 30. Okay, now exit the sketch and go back to the lofted base feature. See here in the profile, delete, clear the selection. First select the sketch 1, the sketch 1 as the first profile, then select the sketch 2, this one, and then select the third one. Click OK. See, now you can see the feature like this. It is little twisted. Let's drag it like this. No, see, now you can see this is the feature, and these are two profiles, and the loft is passing through the third profile we gave to give the direction to it. We can here add constraint like direction vector. You can add this one or this one like this. Bring it to here, bring the connector to here. You can increase the tangency, like if I select 3, now select the end constraint, for this one also bring it here and increase it for like 3. It is going back there. Okay, now select OK. Now you can see this. These are two profiles here, and the loft is passing through the third profile we sketched to give the direction. So now let's go back to the loft feature. The next option here is the sketch tools. It is we left this part for the 3D sketching. Now let's see the thin feature. Okay, now let's loft this one. Select centerline. Okay, now let's go to the thin feature. If I select the thin feature, what thin feature does is to make a cavity inside our feature. As you know, it is one directional mid plane and two directional. That means you will be able to set the thickness on one direction, two direction, and the mid plane option will set same thickness on both directions. This is the thickness. Select as you like, and if I click OK, see there is a cavity made inside my cavity, inside my feature. Okay, so that's the lofted boss or base feature, and that's it for today guys. Thank you for watching. See you in the next video.